Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important and typical type of question from communication systems. And this question is from May-June 2021, paper 4.1. For part A, we need to state what is meant by the amplitude modulation of a radio wave or any type of wave. Let's try to understand what is amplitude modulation. This is our signal. So simply let me write down here. This is the signal. And this is carrier wave is already written here. So this is carrier wave. And this is amplitude modulated wave. If you look at this one, when the displacement of signal, this is positive, the amplitude of amplitude modulated wave is greater than the carrier wave. That when the amplitude of signal is negative, the amplitude of amplitude modulated wave, this is smaller than the amplitude of carrier wave. From here simply we can say that the amplitude of carrier wave changes depending on the displacement of the signal, and that is amplitude modulation. We can also look at this one. You can see this is modulating signal here, and we have here amplitude modulated carrier wave. You can also see when the displacement here is positive, the amplitude of this modulated carrier wave is greater. But when the displacement of signal is negative, amplitude of amplitude modulated carrier wave is smaller, and so on. So amplitude modulation simply means that the amplitude of amplitude modulated carrier wave depends on displacement of the signal. Let's try to define how to write what is meant by amplitude modulation. This is how you can write down amplitude modulation. There are few points you have to be very clear. You need to mention where is in synchrony, means the amplitude of the carrier wave, where is in synchrony with displacement of the information signal. So these things you need to mention to get 2 marks for this part. For part B1, we need to calculate the wavelength of the carrier wave. First of all, we need to understand what is this frequency. This is frequency of carrier wave. Often we write down this is FC. This is frequency of carrier wave. And this upper sideband, this is frequency of carrier wave plus the frequency of signal. And this frequency, this is equal to the frequency of carrier wave minus frequency of information signal. So these are the points we need to understand. So this is also called lower sideband. Let me write down here. This is lower sideband. This is the lower sideband, and this is upper sideband. So this is upper sideband. We also need to be familiar with these names. So this is upper sideband. We need to find the wavelength of the carrier wave, but we have the frequency. The frequency of carrier wave, simply we can write down. This is 300 kilohertz. Be careful with the unit. So this is 300 kilohertz. So simply we can write down this is 3.0 times 10 to 5 hertz. So this is the frequency of carrier wave. Now we need to find out the lambda for this carrier wave. We need to divide the speed of the radio waves, that is equal to speed of light, divided by the frequency of this carrier wave. Speed of light means this is Vc. This is the speed of light, that is simply equal to 3 times 10 to 8 meters per second. But the frequency of the carrier wave we have, that is 3.0 times 10 to 5 hertz. So simply our final answer will be equal to 1000 meter. So this is the wavelength of carrier wave. Now for the next one, we need to find out the bandwidth of the modulated wave. Bandwidth is the range of frequencies occupied by modulated wave. So the bandwidth simply is the range of frequencies occupied by modulated wave. Range of frequencies. You have to be clear with this. Range of frequencies occupied by the modulated wave. So range of frequencies. Now the question is that how we can find that range of frequencies. So the range is this one, means the upper sideband minus lower sideband. This range is called the bandwidth. So this is the bandwidth. This is bandwidth. Simply this is. So in this case we have 308. So we can write down 308 minus 292. So that is simply 308 minus 292 kilohertz, and that is equal to 16 kilohertz. So this is the bandwidth. We can also write down here, this is the bandwidth. So this is how you need to find out bandwidth. Very common question from this chapter. Next one, the maximum frequency of the audio signal. We need to find out the maximum frequency. Now you can see here, this is the frequency of the carrier wave, and this is the frequency of carrier wave plus signal. So from here we can find out the frequency of signal. This is simply equal to frequency of carrier wave plus frequency of signal minus frequency of carrier wave. So simply this is 308 minus this is 300. So our final answer is 8 kilohertz. This is the maximum frequency of information signal, maximum. So this is 8 kilohertz. For part C, the power of a radio signal at a transmitter is given, and that is equal to PT. At a receiver, the received power is given by the following expression. PR is equal to 0.082 PT divided by x square. So this x square. X is the distance here, and this is in meters between the transmitter and the receiver. If x increase, PR will decrease. For the transmission of the signal, attenuation is also given, and that is equal to 73 dB. We need to find the distance x, and answer has to be in meters. This question is simply about attenuation. So this is all about attenuation. So simply we need to write down the formula for attenuation. In this case we will place P in numerator, so our answer will be positive, mean x will be positive, divided by P out. You can also place P out by P in, so then this has to be negative. Attenuation is given, the value of attenuation is given, so that is equal to 73 dB. So simply this is 10 log. We can also draw like this. So let's say this is transmitter, so this is PT, and after a certain distance here we have a receiver, the power is PR, and this is the distance between them, and attenuation between transmitter and receiver, that is 73 dB. P1, so in this case our P input, so we can write down this is P input, and this is the power out at receiver. Now the P in is equal to PT, so simply we can write down this is PT, but PR, this is equal to 0.082 PT divided by x squared. So this is x squared. We need to simplify this. If we simplify, we can write down like this. So this is 10 log. We can write down this is x squared PT divided by 0.082 PT. Now as PT is common, we can cancel this. We simply left with 10 log x squared divided by 0.082. Now simply we have to simplify this one. We can write down here 73 divided by 10. So this is 73 divided by 10. This is equal to log x squared divided by 0.082. Now we can simplify here. We will get this is 7.3, and this is log x squared divided by 0.082. 2. Now simply we need to find value of x from here. The next step we can write down, that will be equal to, we can write down, this is 10 to the power, this is 7.3, and this is equal to x squared divided by 0.082. From here we can find out value of x. X will be equal to 1300 meters, and this is our final answer.